They have a different framework when it comes to time. They're about living life.
They are, I give credit to that.
My family, both sides. In our family social environment, everything is out on Facebook, everything. You yell it out, just get it out. There's no like, nowadays, very, just yell it. It's good and bad,
Yeah, that's right. At times it'll be some problems.
Yeah. But none of my parents' generation. They kept to their
All generations just stuck it out.
stuff it out, even though they didn't get along, right? Stuff it out.
That's not the way. Louis, that's right, right? I'm gonna come home, I'm gonna come home.
June 7th, 2017. I'm Dr. David Bagley, the hearing officer in docket 17-4802 in regards to Brook Mine LLC. Present today from the council are Nick Agopian and myself. Council members Fairservice and Dagenfelder have recused themselves. Parties present today, and I'll do like we did before. I'll mention the party name, and then I'll please ask you to identify yourself, because I know there's been some changing names. Parties present today are Brook Mine LLC. Please introduce yourself.
Jeff Pope, Tom Sansonetti, Isaac Sutton in spirit, and Harry Speck from Holland and Harlan.
Thank you.
Something happened to Isaac?
He's in Italy.
Oh, no, I meant in spirit.
He's still alive.
Okay.
Department of Environmental Quality.
Andrew Pullman and James Brook.
Thank you. Powder River Basin Resource Council.
Hi, good morning. Shannon Anderson on behalf of Powder River Basin Resource Council. I have with me today our director, Jill Morrison, and our expert witnesses, Mr. Jerry Marino and Mr. Mike Weimer.
Thank you. The Fishers.
Jay Gilbert, Reacting Turner on behalf of the Fishers, along with Mary Fisher.
Thank you. And Bighorn Coal.
Good morning, Lynn Bloomberg, Valley Fleck, on behalf of Bighorn Coal, and the today is Mr. Gordon.
Thank you. Also present for the council are Jim Ruby, Executive Officer, and Joe Gerardin, Council Business Coordinator, and Ryan Shellhouse from the Attorney General's Office. This hearing is being held in the Elk Room, Game and Fish Commission, 5400 Bishop Boulevard, Cheyenne, Wyoming. There is a court reporter present. So we have set aside these last 2 days, today and tomorrow, to finish up this final hearing. And we are not able to go past 5 p.m. either day. But we will start tomorrow again at 8:30 if we are still here tomorrow. So we will be done, though, no later than 5 p.m. June 8th, 2017. So I'm saying that, urging everyone to be judicious in their questioning. We certainly want to hear all the questions, but we will also appreciate everybody getting to the point that you can with each and every witness. All right. Guess we're now ready to go. So it's my understanding that Powder River Basin Resource Council has 2 expert witnesses that you intend to call. And so please, Ms. Anderson, call your first witness.
Thank you, Dr. Bagley. I call Dr. Gennaro Marino.
Sir, I'll have you raise your right hand. Do you solemnly swear that the testimony you're about to give will be the truth, the whole truth, and nothing but the truth, so help you God?
Yes, I do.
Thank
No roll.
Dr. Marino, could you please state and spell your full name for the record?
Gennaro Gerald Marino. G-E-N-N-A-R-O. Gerald G-E-R-A-L-D Marino M-A-R-I-N.
And you go by Jerry with a J, right?
Yes, not G.
Okay. Thank you, Dr. Marino. What is your title or position?
I have a geotechnical engineering company. We are about 12 or 14 people, composed of engineers and technicians and administrative staff. I am the president and also the chief engineer of the company.
And what do you do in your capacity as president of Marino Engineering Associates?
I basically oversee the organization. One of my, I think, most important duties is within qualification. In other words, quality control of reports that go out from the company. I also get involved in individual projects that interest me. And you know, obviously, as the president, you're also involved in taking care of our big family. You know.
Okay, thank you. Are you a registered professional engineer in Wyoming?
Yes.
And in other states as well?
Yes.
I have up on the screen POW Exhibit 18. Did you provide this copy of your CV to me?
Yes,
And is it an accurate reflection of your background and qualifications?
yes.
Could you tell us a bit about your educational background?
I received a Bachelor's of Science in Civil Engineering from the University of Dayton. I went to work for about less than a year and realized that I wanted to do more challenging work, and so I went back to school and got a master's at Rutgers University, and then worked for almost 5 years and realized that I really liked high-end work. And to have a good license to do that, I needed a PhD, so I went back to school again at the University of Illinois to get my PhD.
Okay. You also have on your little letters after your name there, a diplomate in geotechnical engineering. What is that?
That's a certification that's awarded to geotechnical engineers that are considered to have higher expertise in the field, one of the cream of the crop, if you will.
How does geotechnical engineering relate to mines and sites?
Basically, geotechnical engineering is related to how the ground behaves mechanically. Basically, you're dealing with the geology and how the geology behaves to how nature or man affects it. And so one of the things that how man affects geology is by mining. I happen to do my PhD in mine subsidence. And so it's a subject that really is not taught in school. I mean, there's not many universities that you'll find that have subsidence engineering courses. Not many people could say that their PhD ended up in something that they could make a business out of or be an expert in and be able to consult.
And there's a lot of different kinds of engineers. So what is it? Do you have anything else to add to what it means to be a subsidence specializing engineer?
Yes, it's a very unique field because it deals with so many aspects. You have the mine stability issues. Okay, obviously it's important to know about the mine stability issues because that's what causes subsidence, right? So the risk of instability is directly proportional to the potential for subsidence in the future. Then you have, and like I said, it's a multidisciplinary field because then you have the propagation of the ground movements to the surface and how they express themselves on the surface. And that's important because if you have structures involved, you need to know what the loading on those structures are going to be so that you can then analyze those structures, right? And so you have to have some understanding of structural response to ground movements. And then you have what can you do to mitigate the subsidence, okay? So there's a lot of different things that you can do, including ground stabilization methods.
Right. And does that mine subsidence experience matter for reviewing a project like this?
Oh, absolutely. Like I said, there's not a lot of people that have this expertise, and you can only, in my mind, regulate as good as you know. If you don't know something, you're not going to be able to regulate it.
Could you tell us a little bit about your background in subsidence review related to coal mines prior to this project?
I've done a lot of basically I've done a lot of review of coal mining permits back, I don't know, many years ago, for both assisting with preparing subsidence control plans and also reviewing them for different individuals, pipeline companies, landowners. I really don't care who it is that we represent. We're interested in good science. And so that's why we've ranged from one group to another to consult with.
Could you tell us about the Distinguished Alumnus Award you received from the University of Illinois?
Yeah, it's an award given every year to people that have graduated from the University of Illinois that have made significant strides either in industry or research or in academics.
Have you published any journal articles or other papers in the field?
I think I have about 100 papers that I've published. The vast majority of them are in the area of mine subsidence.
Have you ever been qualified by a court as an expert witness in a field related to the mine subsidence or geotechnical engineering?
Yes, many times.
Have you ever been qualified as an expert by any administrative agencies?
Yes.
Do you know some of those states in which you've worked and been qualified as an expert?
Illinois, Indiana, Ohio, and West Virginia,
Okay,
and Pennsylvania.
and Pennsylvania. Is there anything else you'd like to share with the Environmental Quality Council about your background or experience?
Then I have a very long history of investigating old coal mines. It probably started back in probably over 35 years, where we've drilled and sampled old mines, and I feel like I have a very good understanding of what a mine goes through in terms of its structure and its stability over time as a result. A lot of that work is related to properties that are undermined that people want to develop, and they want to know what the subsidence risk is. So you have to be able to have the expertise to drill, sample, and analyze these old coal mine structures to assess whether or not there's a significant risk of subsidence on the surface where they're going to put their structures.
You wanted me to ask you about the ASTM CE of the Year award that you received.
I was the civil engineer of the year for middle Illinois section of ASTE.
And what is the ASTM?
The ASTM, I'm a committee member of ASTM. ASTM is American Standards for Testing of Materials. And I'm on the committee that reviews standards for testing of soil and rock.
Dr. Bagley, at this time, the Powder River Basin Resource Council would like to offer Dr. Marino as an expert in the field of geotechnical engineering.
Any objections? Hearing none? That's
Okay.
it?
Thank you. Dr. Marino, just to get it out in the open, are you being compensated for your time here today?
Yes.
And do you feel that compensation in any way influenced any of the opinions you have drawn for these proceedings?
No.
For full disclosure here, do you often consult for nonprofit organizations?
Yes.
And why did you agree to consult for us?
Because you were willing to accept whatever I thought my opinions were.
All right, let's get to your review of the permit application. Could you tell us a bit about the scope of your review?
Basically, I was sent materials by the council to review. The materials that I was sent with the permit application, areas that I requested to be sent to me that were related to the geotechnical issues on subsidence. I also looked at some references that were also sent to me related to subsidence in the area. I looked at some OSM guidance materials as well. I think that's probably about it.
Okay.
But that's given in my report. My report has a list of the major documents that I did review.
All right, I'm going to pull that report up right now. So just for the record, this is our exhibit 12 through 14. We split it up into 3 exhibits just because of the size of the document. There's a lot of maps and diagrams, and so we wanted it to be a little bit smaller. So I'll pull it. So Dr. Marino, could you identify this document for us?
This is a copy of the report that I wrote after review of the mining application for Brook Mine.
Okay. And I think you were just talking about this, but is this the list of parts of the, showing on page 1 and onto page 2, the parts of the application that you reviewed and different reference documents you reviewed?
Yeah.
Okay. Could you explain your main findings and opinions based on your review?
My main findings is basically that the application is severely deficient in analysis and data to be able to make any kind of analysis of what the likelihood of subsidence would be in the future.
Okay. Dr. Marino, have you prepared a PowerPoint presentation for your testimony today?
Yes.
Okay. We'll go through that. And for the record, this is POW POW Exhibit 11, and it's been supplemented just a little bit with some other slides Dr. Marino has put in for demonstrative purposes for his testimony today. So and Dr. Bagley, I'd like Dr. Marino to mainly just testify and talk to you about his presentation, but I may ask some guiding questions along the way, if that's okay with you.
That's fine.
Okay, so if we can,
And yeah, do you want the mouse? Is that easy?
no, I thought- if you could just look in when I say.
Okay, that works.
And I don't know, this is kind of difficult, me pointing up here and the people in the panel, I don't know how to otherwise do it, but I'll try to be considerate and point in both slides if I can. So the way I've arranged my presentation is I know you've heard about the mining method, but I wanted, because it's been a little time, and I want to summarize it maybe in a little bit of different way. The mining method that's been proposed by Brook Mine. And then I want to talk about the mine stability issues related to subsidence, the geological conditions as reported in the application, and then from that go into what the subsidence potential is, and then what the conclusions were that I reached from my review and examination of the information available, and then some suggestions on basically where we could go from here in terms of giving some direction on how the design should be approached. Okay, so this is from the mining application, and you can see the bench configuration where the high wall mining will take place in the coal seams. Note that this seam could also be mined, so it could be benched out as well, with the mining proceeding inward. One of the things to keep in mind is there's been a lot of talk about MSHA. MSHA is the Mine Safety and Health Administration. And their concern is related to obviously, mine safety and health. So their concern would not be in the rooms or entries, because there's not going to be miners in the rooms and entries.
Dr. Bagley, I have to object at this point. What MSHA looks at is not within the scope of Dr. Marino's expert report or the expertise he discussed. MSHA's concerns are laid out in their documents. He is speculating about what MSHA cares about.
Dr. Bagley, first of all, Dr. Marino is an expert and he's allowed to speculate. But second of all, this is testimony and direct response to what was provided earlier by the company and their reliance on the MSHA process to basically bootstrap the geotechnical analysis that DEQ requires.
This is an expert, allows opinion. I imagine you may have questions later.
Thank you, Dr. Beck.
If, for example, in the subsidence control plans that I've reviewed, I'd never seen MSHA mentioned as a reference to be the one who determines whether or not the mine plan is approved for surface subsidence. It's a different issue. They have a different scope. So what they would be concerned about would be, the slope stability issues that you would have on these benches and how they, how that would affect the miners. Here's just some photos to show the hydro mining process. You can see it's bench back. There's no seams up here, but I would imagine that, this would be somewhat what it looked like if you had seams on each bench. But you can see in here, longwall mining, this coal seam down in this area. Next. Here's a close-up of one of these hydro mining cavities. You can see these are the red pillars that we talked about, the smaller pillars. These are the barrier pillars. You can see for this formation where this is happening, the rock here is fairly competent. It's been weathered, but it's not falling off. It's different than the rock that we have at the Brook mine. So looking at the last figure, we saw the red pillars and then the barrier pillars. This is also taken out of the permit. And what I've done in red is put down or summarize what the width of the pillars are and the entries are based on what they say is typical. Okay, so there are two different areas of extraction. You have the extraction between these barrier pillars, and then you have an overall extraction. For mine stability purposes, what we're interested in are these higher extraction areas where the pillars are smaller. And based on the data that's given in the application, the extraction ratios would be on the order of 60 to 70%. So these categories are the pillars. These are the rooms or entries. Up above is the roof, and down below is the floor. And all those, the pillar and the floor and the roof are part of the mine structure. They all have to work together to keep the overburden stable above.
Okay, and for the record, that was slide, it looks like 7, so we're moving on to 8 now.
Okay, so if you've seen probably seen a similar drawing as this is from the mine permit. And the red areas are the areas where there's wind pillar mining that's planned. And what I've done is I've labeled them by number, by block number, from 1 to, I'm not sure what the last number is, 20? Yes, 20. And then between that is where they're going to have those grooves into the ground in order to access those pillars, those coal seams. Okay. So let's talk a little bit about mine stability principles. Again, importance of this is it determines what's the risk of subsidence on the surface.
Okay, we're now on to slide 10.
There are different modes of failure that can cause surface subsidence. And we'll go through each one of these in detail. The first is a roof caving failure. That means right in where the void is created, the roof collapses individually and propagates up to the ground surface. The pillars, you can have the pillars have too much load on them and they crush out. Or you can have a bearing failure. What that means is the pillar is strong enough, but the roof or floor isn't. And so it'll either sink into the roof or sink into the floor.
Are we okay with
Building
that?
subsides.
Going forward, okay.
So this is kind of my illustration of a roof collapse in a room. There's the room or entry or void space. Here's the coal on both sides. And so originally there was a roof here, but all this material collapsed down and it breached the bedrock surface. And once it breaches the bedrock surface, the soil itself has no bridging capacity over the long term. And so it'll just follow suit. So what is that room thin capacity factors? What are they? What are the things that you need to look for when you're assessing subsidence potential as with the subsidence control plan? One of the things that you need to know is the durability of the beds. Now, what I mean by durability is kind of the definition you would think. It is rock material that does not degrade. Okay, there's certain rocks that will degrade. Like if you have a rock that has a lot of clay in it, it'll degrade. Clay is the finest grain earth particle there is. And when you get to the size of the finest grains of clay, they have significant water absorption characteristics. They get exposed to water and they break down and they swell and they lose their strength significantly. So it's important to find out what are our durable beds. What are the durables that are going to bridge over from pillar to pillar? We also don't even know what the thickness of those beds are, because if it's a thin durable bed, it's not going to be able to bridge. It's got to have a sufficient thickness to bridge from pillar to pillar. What is the strength of the bed? Okay, in other words, okay, it has some durability, but does it have enough strength also to bridge? And the last but not least is rock structure. Okay, rock structure is the fractures that exist in the rock. Rock isn't perfect, it has fractures in it. And we know here, and we'll get into a little later, that there is faults in this area. So that's significant rock structure. The rock is going to be broken around it. The durable beds are going to be broken, so they're not going to have significant bridging capacity in those areas. The other mode of failure is pillar failure. This is my illustration of it. It could be a lot of different ways, but this is the way I decided to show it. Basically, the pillar is crushed out. Okay, the load on the pillars is too great, and it crushes out and causes it to fail. Normally, when you have something like that, it's not one pillar, because the roof didn't fail, right? So if this one pillar fails, you're going to have an adjacent one and another one adjacent to it on either side that is also going to fail. And you're going to have a larger bulb subside ground surface. Normally, those are much more abrupt when they occur. What does the pillar strength depend on? And there's some innuendos, some inferences of attempts at calculating that, and in the application permit, but there's no equations given, there's no strengths given, there's no strength data. So it's difficult to know when you look at these different parameters that the pillar strength depends on, pole strength. Okay, the pillar, the equation that is said to be used, which is not explained very well in the permit, is an equation for what's called bituminous coal. Just so you understand the differences, there are different grades of coal. Okay, you have just basic grades. You have lignite, find that in a lot of times in Texas. There's a lot of fields of lignite in Texas. You have subbituminous coal, and you have bituminous coal, and you have anthracite. And anthracite is the highest grade of coal. And anthracite also has the highest strength. The equation that is used, and we don't know for sure what strength was used, but the one that's inferred in the equation is for bituminous coal. We have subbituminous coal. And there's no data that I found in the permit, or I can find in my research, on subbituminous coal and what that strength is, and how that strength changes when it become a large cube size, which is really what you use in the pillar strength formula. Pillar height. Okay, pillar height, if you look at the geologic cross section, okay, and we'll get to those, you'll see that the height changes all over the place. There's quite a variation, and you don't get an understanding in the permit on how does that affect the overall pillar strength. And then you have the pillar width and length, the dimensions of the pillar and plan. Now, in our case, we don't have length because they're just long rows of pillars. So it depends on the width also of the pillar. So all these different characteristics play a significant role in what the ultimate strength of the pillar is. Then you have bearing capacity failures. This actually is my favorite mode of mine failure. And the reason why, I guess, is because it's more challenging to analyze. What I'm showing here is a pillar that's punching into the floor. You can see the floor is heaving up on both sides. Okay, and you also see these tension cracks that develop, and that's because the material is stretching. The material is moving out from underneath the pillar and causing tension cracks. It's called rashing in the pillar to occur. And as a result of that, the pillar itself doesn't have the stress confinement it used to have. So it could fail, or you have a failure just as a result of punching into the floor because of the softer material. In our case, from reading the permit, the vast majority of the material is clay stone. Okay, that's for the roof and floor. Clay stone is not a very good engineering material. Clay stone is made of clay. And when that gets exposed to water, it deteriorates, it softens and swells, and it causes failure. A lot of the failures that occur over time occur as a result of these materials softening from groundwater conditions. Obviously, if failure doesn't occur right away, something has deteriorated. Simply, right? Well, what causes it to deteriorate? Water and these materials that are non-durable. So it's important to identify where these durable materials and undurable materials are. And there's not even a mention of that in the application. There's no mention of failure from roof or pillar condition. I'm sorry, roof or floor conditions in terms of analysis or safety factors or anything like that. Okay. So what does that depend on? Let's take a little bit more narrow view on what should we be looking for. It really, the first item, strength and thickness of non-durable zone. Obviously, non-durable means it's not durable, okay? It's a clay stone, it's some material that deteriorates. And where that exists right below the pillar or above the pillar, that's a significant concern because that's where all the bearing pressure is going to be focused. So the strength of that in the long term and the thickness, obviously if it's only, say, a few inches thick and you have a pillar that's, say, 10 feet wide, no significance, right? But if you have pillar 10 feet wide and the thickness of that floor material that's non-durable is 10 feet thick, that makes a big difference in what the overall strength is going to be. Again, we have structure. Structure again being the fracturing characteristics. What I found is, from my experience, that where these materials have a lot of microfractures in it, it reduces the strength significantly, even in the short term. Doesn't even have to have any softening effects. You can imagine, a rock with all these intense microfractures versus a solid piece of rock, big difference in strength. So also important is to find out what is the resistance zone below, right? In other words, okay, we have this much soft material or non-durable material, and now we have a resistant zone. That is going to be the zone that's going to resist the shearing failure from below. Does it have enough capacity at what depth? So that has to also be defined if you are going to determine the bearing capacity of the roof or the floor in terms of, or failure, in terms of a subsidence potential. And, we talked about this, the width makes a big difference. The width ratio to the weakness of thickness of material below, that ratio determines also the capacity of the floor or roof. Okay. Here's another instance to consider, is that say you have a non-durable roof, and you have groundwater that oscillates in it. Okay, when it's in the band of mountains, so it starts caving up. And as it's caving up, this water level is going up and down with seasonal variations. And what happens? It dries and wets these materials and causes them to break off and create a greater cave or arch zone. In essence, causing a larger or higher pillar and also causing this cave zone to propagate upwards. What I've tried to do here is basically kind of summarize just what I said, and with depth, okay? And so what we have here, here's the soil layer, okay? And then we have, this is top of rock, and then we have the roof, a rock overburden here. This is the coal that's being mined out. And then below you have the floor. Now, when you're at a shallow depth like this mine, we go from very shallow depths to very deep depths, like up to about 400 feet. So we've got this whole spectrum here that could be present. So at shallower depths, where the pressure on the pillars isn't so great, you wouldn't, even if you had non-durable soft floor conditions, you wouldn't expect the floor to be, for the pillars to squeeze into the floor because the pressures aren't high enough. The only thing that you would be concerned about would be for the ground above these void areas to propagate upwards and create a sink on the surface. What could mitigate that is if you identified this durable zone, like we have shown here as an illustration, then you can propagate up and you'll go to that durable zone and it won't go any further. I've done studies where we have this massive sandstone, you don't see any subsidence, okay? So, and then as we go deeper, now the stresses on the pillars become greater. And to the point where the soft floor conditions cannot hold it up. Even though you have a durable rock zone above, it's not going to be able to bridge, say, a massive pillar squeeze condition or floor squeeze condition. So you'd have a series of these pillars that are squeezing into the floor and causing a bowl-shaped depression on the surface despite having this rigid layer of rock here. I have a case right now that's, this started out being 600 feet, and now it's 1,200 feet. It's 200-foot deep mine, and it has a very decent rock above, but the floor is terrible. And so it's collapsed and it bridged over, even though great rock on the top. And so then, if we take a better look at the floor, and what I've done is I've drawn in this gray zone here. That's the durable resistant zone. So now you've thinned that soft zone between the coal and the durable zone, or here from here to here. You can see it's only, the blue is very thin. And it's so thin that it's not going to cause a bearing failure, right? So the only thing at that point you would be concerned about is pillar failure, right? That would be the only thing that could cause any problems, because you're not going to have a collapse in the void because it's way too far below the ground surface, and it reached the ground surface. And then you have a condition even deeper where we have resistant layers on both top and bottom. And you see that in the Appalachian fields, since most of the rocks, the roof rocks and the floor rocks are fairly durable and competent rocks. In other words, they don't have claystone. It may be pockets here and there, but they don't have claystone. They're more durable rocks. And so all you'd be concerned about then is pillar safety factors. What's the safety factor of the pillars? Okay. So just to orient you on safety factor, okay, this is in our field, this is a common term. In civil engineering, this is a very common term that's used to determine the risk of a design. Normally, there's a ratio that's established in design codes that tells you, okay, if I get above this ratio, we should be okay. And that's based on empirical evidence, right? So it's the ratio of available capacity over the overburden load. So in other words, let's take this table here. And this table, say, is rated for 500 pounds, right? We put 100 pounds on it so that we would have a safety factor of 5, okay? It's rated, when I say rated, that's the 500 pounds is what it's expected to collapse at, okay? So if we put 250 pounds on it, that's a safety factor of 2. Now the code might say, well, if you have a safety factor of 2, it's acceptable design. So you're only allowed to put 250 pounds on this thing. And that's how it works when you use safety factor in design and civil engineering projects. Next. And as you know, Dr. Bagley is an engineer. You know, it all depends on your input data, prediction method, and the calculated capacity, okay? If you have poor input data, like we have here, we don't have hardly any input data. If you don't have the right input data, even if you have the right prediction method, your calculated value is suspect. So you have to have these two building blocks. You have to have enough input data for the circumstances that you have, the type of circumstance. And that's a lot of that is engineering judgment, especially in this case because we have such a variety of mining conditions and geologic conditions. And then you have to use the appropriate prediction method to assess what the capacity is. This kind of summarizes it in a different way. Low safety factors, obviously high risk. High safety factors, negligible risk. So if you calculate, you do all your homework, you do it right, and you have high safety factor, you're going to have negligible risk of subsidence. And so, you know, this scale summarizes in another way how the subsidence risk relates to the safety factor. And obviously that factor, as in any kind of engineering, you know, is a quality of, it's a function of the knowledge and experience of whoever's doing the work. So this is summarizes, the flow chart summarizes again, you have immediate roof collapse, different elements that can cause subsidence on the ground surface. It starts out at line level. You can have the immediate roof collapse or the void collapse. You can have the pillar crushing, or you can have the pillar punching into the floor or roof from bearing failure. And then ultimately the roof has to fail above it, and then you have surface subsidence. Okay, so let's look at now what we understand from the reported conditions from the application. This is a drawing that's taken out of the application. I've put my block numbers on it, 1 through 20. You can see all these lines with alphabetized lines. Those represent slices that are taken through the ground. Okay, in other words, there's been holes that have been drilled along these lines or close to these lines, drill holes, where they've been able to classify the different geological materials. And so what was done to summarize and understand how these materials are continuous across the mine site. I mean, we're talking about 7 miles from here to here. These slices are taken through the ground to see where the coal seams are and what are the other rocks related to it. Also, what is shown on here is you see these D nomenclatures and then these lines. Those are fault lines. And the D means that side is dropped and the other side went up to the fault. Okay? But there's not a lot of data given on the fault. All we know is these lines. We don't know what the inclination of the fault is, how it's fractured. Don't know any of that. This type of arrangement of faults represents what's called a horse and gabbin geologic formation. In other words, in between the faults, like here and here, the rock is, one side is up versus the other side being down. So if you went across, you'd have one side up, other side down, fault, the next side's up, and they just kind of oscillate like that. That's from tectonic activity in the past. Okay. So this is one of those cross sections. This goes east to west. And this is the section AA. And what I'm trying to show here is really is the variability of what the mining conditions are. You can see on top here for reference, these are the block numbers. So these are the areas where the room pillars would be, where this cross section, this slice through the ground was taken. So you can see block numbers like this is block number 10, 9, 7, it goes all the way to 6, right? 6 down over here on the side. And so what it shows here is we have a thin cover above this. This is a coal seam here, right? There's thin cover above that coal seam. It's in a valley. You know, if the valley fills up with water and there's propagation of a subsidence from a roof collapse above, where's that water going to go? It's going to go into the mine. Then you have what I've called thin interburden. Interburden is basically a term that's used in the mining industry for the amount of rock in between the coal seams. So it's important to know what the interburden is, because if you're going to mine two seams, the stresses could overlap if they're too close. And so you have a more complicated stability condition. And so we have thin interburden here between these two coal seams that are planned to be mined. We have, again, the faulting here. And then on this side, we have deep cover, right? These coal seams are mined, but they're under deep cover. So you can see the variation just in one cross section of the different conditions we have. Next slide. Here, again, we have thin interburden in between the coal seams. Again, thin cover up here. We have also the potential for flooding. If these coal seams here are mined out and water fills in this ravine, you can have flooding of that mined out area. Next. Oh, hold on. And then you can see a seam split. That's important in this case is because there's a question of, you have this whole seam that's going to be excavated. But at some point, going to the west, it starts splitting and there's a clay in between, a clay parting, and it gets wider and wider. Well, that clay parting plays a role in the composite of the pillar strength, right? At some point, it's going to get so thick, if you leave it in place, it's going to really compromise the coal strength, especially if it's clay and it gets exposed to water. Where's the criteria? Where's the analysis that tells us what that limit is? There's no such analysis. Here they talk about two seams, but there's actually four mineable seams here. You have the Dietz seam, the Monarch seam, the Kearney, and then the Masters. And it's been offset, as I talked to you about before, from the faulting. This layer at one time was up here before the faulting. This layer here was up here at one time. You have water that comes along the faulting that can recharge these areas where there's going to be mining. Here we have another condition of deep surface way up here. We have deep mining condition. Okay, next. Faulting again. Seam splits. Again, we talked about that, the partings between the seams. And another seam split here. So, we've got a variety of different depths, different thicknesses of coal, different interburden thicknesses, different seam splits. None of this is really addressed in the permit, in the application. Here again, deep cover, thin interburden between these two seams, seam splits. Okay. Here's an interesting, I guess it's not interesting, but another problematic condition. This is what Warren Cole is concerned about is all this darker gray material, which is all stripped, dumped, backfill material. And if it's all made of claystone and saturated, how the heck are you going to drive through that without having slope problems? In my mind, to me, this would be the last place you'd want to mine. I mean, is this a well thought out plan comes to my mind is why would you want to deal with this first? It's a significant slope problem. I don't know if MSHA would even allow it to be done. I don't know. It's a slope condition, it's a mine safety condition. So from those different cross sections where we delineated where all the blocks were, we picked out all the seams that look like they could be mined. And also we categorized, and you can look at this when you have an opportunity, you can see the varying thicknesses of the coal. And then you see the depth of the coal, and you'll see it goes up to about 400 feet. And what we've got here is I've shown where the durable zones as they are delineated on the cross section. So some places they exist. Sometimes they're, in the roof and on the floor, but they're usually too far away from the pillar to make a difference. They could make a difference where you have the cave collapsing upwards, the roof collapsing upwards. WP means where present. That means it wasn't present along the whole section where that block was. Again, this is the summary of that table, basically. So, basically, as I've been saying, there's a variety of conditions. The coal cover depth for all the seams goes from the ground surface to 420 feet. So you've got a variety of coal pressure. You have the pressure on the coal is going to be different depending upon where you're mining. The extraction height is from 2.5, and this is about, because we don't really know what the extraction height is going to be. Completely, the miner, they talk about the miner being able to do up to 28 feet. If you look at seams, two seams come together, the Masters and the Carney, where they come together, you can get up to 25 feet. But what's more boring, you don't know how much variation there's going to be with that. I use 20 here as an approximate number. The panel extraction is 60 to 70%. That's what we're talking about in the panel itself between the barrier pillars. The only thing that is set in the permit is that they will not have the minimum pillar to width ratio will be 1. In other words, to make the pillar as wide as it is high. Is that enough? If you use that, you don't get a safety factor of 1 when you get to the deeper depths. But that's not really discussed. It's just a general, there's no detailed analysis of the varying conditions. And we have roof and floor mainly of claystone, which is not a good engineering material. Okay, so in discussion of this site, what is the possible expressions that you could see on the ground surface as a result of the different types of mine instabilities that are possible? This is a drawing that I took out of a publication, I believe was 1980, by the USGS, where they did a study in Sheridan County on subsidence. And this is their depiction of what the subsidence looks like. And you can see here what we talked about before about the rooms caving in, right? And eventually coming to the surface and having these sinkholes that develop on the ground surface, as here. On this side, and we'll talk about this also, is more of a bowl-shaped depression where, you've got a massive collapse here of the pillars or the floor that causes this whole area to go. And there could have been, what I think the authors were trying to depict here is that there were also some initial pits or sinkholes prior to the collapse of the whole area. So one calculation that is made in the permit application is with regard to explaining the collapse over the areas of mining that exist in the area and showing a relationship of that to what the mining conditions were, using a certain formula. And this is purely for the caving up through the mine entry conditions. Using the same formula and the same extraction height, which they didn't do for some reason. They didn't do it for their condition. They did it for these older mines. But if you take the same formula, and you can do it on your own, and you plug in what they're proposing, you end up with the potential to have pit subsidence over 200 feet deep. And this includes only one extraction height. There's a mention in the report that they plan to stack the pillars. In other words, if you're mining one seam, the seam below, they'll put the pillars right underneath right underneath the pillars above. So essentially you have accumulated void height. So you might have 14 feet, interburden of 30 feet, and then you might have 10 feet more extraction height. So in essence, you've got 24 feet of extraction height, and that should be considered if you're doing this kind of a calculation. What we did is we did look at some air photos in the area. Here is the outline of the proposed mine application. And then you see in yellow the areas where there's subsidence shown as a result of old mining. What I wanted to show here, let's look at area A. Next one. Here you can see all the dotted pattern showing all the subsidence within that area. And based on the information available, this subsidence, it goes up to about 160 feet deep. So the other condition, as we discussed, would be these sag subsidences, these bowl-shaped depressions, depending upon extraction height and extraction ratio. They could maybe be up to 9 or 10 feet deep in the center. And they would have tension cracks on the outside form as a result of the subsidence. So looking at the potential for that to happen, we're looking at pillar failure, right? The massive pillar failure, number of pillars failing, and the roof above it collapsing, and a larger area subsiding. We measure, we had calculated up to almost 1,300 PSI on the pillar, given the extraction ratios we looked at in the permit. If you use the formula that's used in that standard formula that's used for pillar testing, pillar calculations for strength, you end up with safety factors less than 1. So there's no discussion of, all there is a minimum of 1 safety factor. Well, it doesn't really give us enough to say if they're going to be able to control subsidence. There's no significant clay seam assumed in the analysis. As I said before, the formula that's used is a formula where they use the bituminous coal strength. They didn't use the strength that's for subbituminous coal. Do we know that the entries are going to be truly parallel? I understand that they can control the direction, but I'm not sure how the azimuth is controlled and how much error there is there. And then the formula that is used, there's a qualification in the formula saying that this formula was developed based on coal heights of 7 feet or less. Okay, we've got heights much higher than that, and that's not addressed at all. Okay. Here, again, sag subsidence, the bowl-shaped subsidence. Now, it could be from roof or pillar bearing failure. Again, we have the same bearing pressures that could come up. There are places that'll be less than 1. If it has this clay zone that the vast majority, talk about the vast majority of the geologic section consists of, from my experience, this clay stone capacity could be as low as 300 PSI, way below the maximum, but even, and you want safety factors of at least 2, right? So when you get to pillar pressures of 600, you start getting concerned about long-term conditions related to pillar, roof, or floor capacity. Also, as I mentioned in my illustration, when you get yielding of the floor, you can also cause the pillar to collapse because it's stretching apart the pillar. So you can, in essence, get yielding in the floor, maybe not complete yielding. Pillar separates from the stretching and then collapses because it's not intact anymore. So in conclusion, as I mentioned, there's really not a lot of engineering, geologic, or geotechnical information related to the mining interval. The subsidence control plan exhibits a lack of a geomechanical understanding of short-term and long-term stability proposed with multi-seam mining or even single-seam mining. And in my opinion, that there is insufficient information, very limited analysis, that the subsidence potential cannot be reasonably determined. But if it is this clay stone, as stated, you're going to have problems. And for it to be a control plan, in my mind, control means you're controlling it. You have to demonstrate that you're controlling it. That is demonstrated in the permit application. From my view of subsidence control plans that I've looked at over the years, this is far below industry standards. And as I said, given what's reported in the there's a serious risk of subsidence that will occur, even with the idea that's been proposed of we'll submit design, 1 month before. Well, that doesn't really give any opportunity to do any check. Sort of we'll see how it goes kind of attitude. I mean, I don't think that's regulatory. Next slide. So what I've done is like I said, I hope this is a help, and that was the reason I'm proffering this, is to give some idea of what some of the things that in a general way that should be done to assess the mine risk. Identification of the non-durable and durable zones. You can go next slide. And what I have done here is just to show you near the site at the Bighorn property, where we have these outcrops here, right? Those are the durable rocks, okay? Those are the durable rocks. They've sustained weathering, right? They're intact. And then below, you see all the sloped soil material. That used to be rock. That's the material we're talking about that's non-durable. That reverts to rock over time. methodology to assess the potential for chimney subsidence. So I proffered that also as well, what that methodology would be. Methodology to assess the potential for a broad or large subsidence. We talked about that. That's the pillar failure and the bearing capacity failure. But it also needs to somehow assess what these significant engineering geologic features are and how they affect the mine structure, the faulting, for example, that's already been reported in the area. Thank you.
I think this is a good time for a break.
Oh, sure.
So let us take 10 minutes, back at 10:26.
I also received that.
Their demonstrative exhibit, which I'm distributing to folks. Shannon. All right, and Dr. Marino, did you prepare this document?
Yes.
And can you explain briefly what it is?
The purpose of this document was to help explain my views on the approach that should be taken in terms of the subsidence control plan, in terms of the design of the room pillar mine or the high wall mine. And what I've tried to address here in different items is basically what we've talked about, summarized in a way that kind of gives guidelines to step by step how to go about baking the cake, if you will. You can see it's void of basically equations, and that was purposely done because I didn't want it to be too restrictive. I have my favorite equations or how I would want to do it, but a lot of times you'll see in here appropriate analysis or words like that qualifying the methodology used, ample data, kinds of things of that nature. But I think it's a good basic step to provide guidance to appropriate measures that should be taken in a subsidence control plan.
Okay, and could you briefly summarize some of the sections in this document?
Yes, so section 1 deals with roof entry failure analysis. This is the analysis where we go about determining the potential for the void itself collapsing and propagating to the ground surface. And 2 is the pillar failure analysis. The pillar failure analysis is basically looking at the potential for the pillar to collapse and cause a broad size subsidence to occur, and the steps that would be taken to do that. And you can see the longest one is really related to on the guidelines is section 3 on roof and floor bearing analysis, failure analysis. And the reason why that is because of the different geological scenarios that you can have. If you can, in terms of where the durable layer is it right underneath the coal or up right above the coal? How thick the non-durable layer is it all non-durable? Is it all durable? So all those, I tried to address all those different instances, the most common instances.
Excuse me.
Yes.
The copy we got just is pages 1, 3, and 5.
Oh.
Pages 2 and 4, I think, were double-sided.
Oh, that would be my error. I'm sorry about that.
As long as we get the record and get the full copy.
Okay.
Mine is a full copy. This is.
Yeah, that was the one I copied, and then it was a copying error on my part.
Okay.
So yeah, I will make sure that happens. Thank you. Sorry about that. I can also email it to the parties. I'll do that.
And there's a statement at the end about, and this does not include any significant engineering geologic features that might be present. And also qualifies that there should be enough borings performed to determine what the variability is, so that there is an unlikely chance that an adverse ground condition was not uncovered.
Okay. So is it a fair summary to say this is things that you would
try and do if you were going to prepare the subsidence control plan?
Yes.
All right. Dr. Marino, I have some questions for you about some of the testimony earlier from the proceedings. Were you present for Mr. Barron's testimony?
Yes.
And do you remember him describing a pillar design methodology that the mine plans to use called the ARMPS?
Yes. Analysis of retreat mining pillar analysis.
Okay. And can you explain what that is?
It's a methodology that's fairly accepted in the coal industry as a standard. It defines the coal strength and provides guidance on what safety factors to use for short-term and long-term conditions. As I mentioned in my presentation, there are certain inputs that need to be made when you're using that equation. The coal strength, for example, is an important one. There's no data on the coal strength. What was used, is the default value that's given in the program. And this is for bituminous coals, not for subbituminous coals. And then again, there's a qualification given that this safety factor, this equation, and it's an equation that's used for not only for high wall mining, but it's the same equation that's used for standard room of pillar mining, and it's used for long wall mining. It's called the Mark-Beniowski equation. Excuse me. Because we really have the same situation. We have pillars and rooms. But it talks about that this is based on case histories where the mining has occurred with extraction heights less than 7 feet or at or less than 7 feet. Here we're talking about potentially 20 feet or more up to.
Okay. Did you hear a lot of testimony earlier about the TR1 area?
Yes.
And you touched a little bit on this on your presentation, but do you have any concerns about high wall mining in that area?
Yes, I've done a lot of slope stability analysis as a geotechnical engineer as part of the wolf and warp, if you will, of our profession. And when you have heterogeneous material that's just dumped in place, saturated, it's over maybe 100 feet high, and you're going to cut into it. It just boggles my mind. I don't know. I don't think you could get it past MSHA. I don't know, but it's going to be very difficult. If you do, it's going to have to be so flat. You have to take so much of that material out. And just as an engineer looking at this scenario without any data, engineering judgment tells me, why would you want to do that first? That is going to be so challenging. I would start where it's going to be the easiest, right?
And just to kind of relate it back to the permit application and the subsidence control plan, is there anything in there that discusses these risks that you just mentioned?
Well, that's not really a subsidence control issue. Yeah. I mean, that's more of a MSHA issue.
Okay. Did you also hear some testimony about this 50% extraction limit?
Yes.
And how maybe that could help prevent subsidence?
Yes, that comes from an old standard back in the 70s about protecting structures, and that you should use a 50% extraction limit. That standard, obviously, it really doesn't apply if you have safety factors that are lower than what are acceptable. It should be based on safety factors, not on a percent. It's like well, we don't know what to do, we'll just say 50% is okay. Instead of actually calculating what's, what is the risk?
And based on your presentation, you believe that the extraction may actually be higher than 50%.
Excuse me?
That the extraction may be higher than 50%?
Yeah, well, based on the typical range of the web and entry widths that are given in the permit, they are higher than that, yes.
Were you here when Mr. Barron testified that the Wyoming mine permit application subsidence control plan was quite extensive and in other states is often one page?
Yeah, that's not my experience at all. I mean, I believe I believe he was referring to the entire permit, but all these permits are very extensive. They're not one page. They're all extensive permits.
Okay. And is it your testimony that you've seen subsidence control plans with a greater level of detail than the one here?
Yes. And not relying, there's nothing in them about MSHA because MSHA, it's not directly related to subsidence on the ground surface.
Okay, and we'll get to that in just a minute. In your opinion, does the application provide sufficient information to provide a meaningful peer review with respect to subsidence potential? So if you were in the shoes of DEQ, would you be able to review this?
Objection calls for speculation. He isn't part of DEQ.
And Dr. Bagley, he's an expert. He's allowed to speculate. He's providing his professional opinion on the quality of work provided by the company.
On the other hand, he's just provided a review, which is clear. Go ahead and answer.
Okay, is there anything else you want to say about the ability to do a peer review of this document?
No, as the chairman said, I think it was pretty clear.
Okay. Do you have an opinion on whether the subsidence control plan should be certified by a professional engineer?
All the ones I've seen have been. I mean, it basically says when it's stamped that I take responsibility for it, and I believe that this is a valid subsidence control plan.
And were you here for the testimony from Mr. Barron that he didn't stamp the subsidence control plan?
Yes.
So does the lack of that stamp from his PE stamp, even from a layperson's perspective, give you any confidence that the subsidence control plan is complete and technically accurate?
Well, from my experience of working in other states, there's always a PE stamp for engineering work, always. It may not be the same person, but there's always, if you're doing engineering work, there's a stamp for it. Otherwise, you're practicing without a license.
Okay. In your opinion, do you believe there should be significant revisions to the permit when the design is complete for an area?
If there is when an area, a significant revision in my mind means there's let me step back.
Yeah.
This mine application is all in one. My experience has been normally you get a permit for an area that's got all the detail that you need to get your subsidence control plan done. And then you work that area, and then you put in a significant revision for the next area. And then you provide the data for that area. Not everything all at once where there's not any data for anything.
Okay. Were you here when there was testimony about this, quote, directionally intelligent miner?
Dr. Bagley, I'm going to have to object. I know that Ms. Anderson wants to have Dr. Marino rebut some of the earlier testimony. None of this information is in his expert report. The reason that this council set the scheduling order to have expert reports was to have the ability for parties to understand what each expert is inquire with Dr. Marino on this, and he was also not designated as a rebuttal expert. What was the opportunity?
And Dr. Bagley, I think all of the witnesses throughout this whole hearing have been testifying to what they've heard from other witnesses. This is no different than that.
Could you repeat the question?
Sure, it's about the directionally intelligent minor. And if, I'm gonna ask Dr. Marino if he has an opinion on that.
You could go ahead and ask. I'm not sure he's been qualified as a mining engineering expert. So let's be careful how far you push that. I mean, his credentials as a geotechnical expert, well described, but mining engineering starts to push into that area.
Sure, and I think he appreciates that. Dr. Marino, do you have an opinion on the subsidence prevention capability of this directionally intelligent, as it's been phrased to us, minor?
I can't say I'm an expert in mining equipment, mining excavation. So I don't see the relationship between that and subsidence. It really has to do with the mine plan and how it's going to be developed and what ends up being there.
Okay, thank you. Okay, Mr. Barron talked a lot about this MSHA ground control plan. And I'm going to pull up Brook 10C, which has some of that in there. Dr. Marino, do you have anything to say about Mr. Barron's testimony related to the MSHA permit?
Well, it says right there what the ground control plan is for. And if you read through it, you'll see it's for safe working conditions. It's all about workers and hazards, not related to, it doesn't say anything about subsidence.
Okay. And do you believe that the mission of MSHA is similar to the mission of DEQ in permitting a new coal mine?
No. I mean, I don't know if there are areas that intertwine, but in terms of the subsidence control plan, no.
Okay, so is it your opinion and based on your experience that the MSHA process and the DEQ process are different?
Objection, Dr. Bagley, is the same one. These are not opinions that Dr. Marino has in his expert report. He also not qualified himself as an expert in the regulatory process.
Actually, I would agree. Now we're asking for, is this regulatory agency, does this, I think we need to come at this a different way.
Okay, thank you. We'll stick to the deficiencies in the subsidence control plan. All right. So at this time, though, you didn't have a chance to review this permit, the MSHA permit. It wasn't part of the subsidence control plan.
I don't know of any that has been submitted.
Okay. And I guess based on that, do you have any recommendations for testing and analyses beyond what will be required by MSHA later that should be required now as part of the subsidence control plan?
Objection, same issue. This is speaking to the regulatory process.
Dr. Bagley, I think Dr. Marino has testified that he's reviewed numerous subsidence control plans and has served as an expert in various capacity for those control plans. So I think he has a very good understanding of what should go in the subsidence control plan.
I think the question should be what testing is may be required to specifically get at subsidence control plan. MSHA may have, like it does have its own testing. That's not for us to decide. I understand that that's what we're asking, but we can hear what his recommendations are to get at subsidence issues.
Yes, the testing, types of testing, I've already outlined in my report for testing durable materials, what tests tell you if it's durable or not, and how to determine what the strength is. When it reverts back to a soil, what that strength is. That's all given in my report.
Okay. And Dr. Marino, in your expert opinion, do you consider the permit application as it currently stands technically adequate?
Objection.
same issue. He's not an expert in the regulatory process.
Dr. Bradley, I think he has an
Yeah,
opinion
the
on whether
question
it's
is, is it
technically.
technically adequate? He's a technical expert, so allow his opinion on this issue.
Mr. Hearing Officer, I'm gonna object that he is not established, he's familiar with what technical adequacy means under Wyoming law.
You bring up a really good question, which we'll probably have discussion on later.
Yes.
I would like to hear his opinion on the, in his technical, as I understand it, as an engineer, and as Dr. Marino as an engineer, his views of the technical, not the legal parts, which I don't consider technical, but, so I'd like to go ahead and, but thanks for the objection, for the way I'm asking. Happy to answer the question.
In my mind, it's not complete in a technical form because there's not enough information to evaluate the various mining scenarios and the various geologic conditions.
Okay, thank you. So you've heard some of the testimony that there will be some additional tests later on for MSHA or maybe something else. Do you have any concerns about giving the company the right to mine via permit at this time?
Well, that, you know, those statements about we're going to provide testing and analysis, I mean, what does that mean? There's no detail about what that means and how it's going to be done. And it's kind of putting the cart before the horse, you know, in terms of determining the subsidence control plan.
Okay. Understanding I may get an objection here. Dr. Marino, if you were sitting in the chair of the director downtown in Cheyenne for DEQ, would you feel comfortable approving this permit as it currently stands?
Objection. He's not part of DEQ. He's not the director and not an expert in that process.
I agree, that's, he can't make that.
Okay.
Okay, that's
Okay.
fine. Dr. Marino, I think that's all I have for you unless there's something else you am remembering that you want to tell the council.
Maybe on cross, I might think of some.
Okay, great. Well, thank you. So that concludes my direct examination.
Great, thank you. So I have taken an order for cross, it could be a surprise. Mr. Gilbert.
Thank you. Still good morning, Dr. Marino. Just a couple of questions. You said at the beginning of your testimony that your primary goal was to be involved in good science. From your perspective, has any good science went into the prediction of the potential for subsidence of the Brook mine?
There's no science there. I mean, I'm not saying it's, I'd like to see the science. There's no science. In essence.
I think you inferred this, but was never said directly. You talked about the fact that in this model or the work that was done, there was an assumption or a use of a formula that involved an amount in relation to bituminous gold instead of sub-bituminous.
An amount?
Yeah, it said that an amount was placed into the calculation which relied upon the coal being bituminous.
Yes.
And you told us that in fact this coal is sub-bituminous.
Right.
I think there's an implication here, but you never really said it. Will the sub-bituminous have a greater or lesser strength than the bituminous?
In general, lesser strength.
And then I just wanted to confirm something I heard you say, and I will butcher the name. Is it Fenikowski?
Beniowski.
Beniowski, thank you. And did you say that that formula has a qualification on it that it should not be used when the extraction heights exceed 7 feet?
First, I have to correct it. It's Mark Beniowski. Actually, Beniowski was a professor at Pennsylvania, Penn State. Mark worked under him, Chris Mark worked under him, and he modified his equation.
Very good.
And it was for, yes, the equation was developed for pillars with extraction heights of less than 7 feet.
So from your perspective and your qualifications, is it appropriate to use that formula as with confidence for extraction heights that exceed 7 feet?
I have not done an analysis to say one way or another, but it's something that needs to be addressed.
Without having done the assessment you've told us is necessary to understand the risk of subsidence, do you believe that without knowing the risks, a reclamation plan can be developed that assures reclamation?
Objection, Dr. Bagley. We're now outside the scope of Dr. Marino's expert report. I understand that Mr. Gilbert's was not involved in preparing that report, but again, that's the reason why a report exists, why the rules of civil procedure are set up the way they are, and why the council set up the scheduling order the way it did.
Well, I think what we have is the potential for subsidence, which is going to then require reclamation. And my question for him is, without knowing the risks of the subsidence fully, can we get to a place where we can predict the reclamation as it relates to subsidence?
Yeah, I'll allow that question, focusing on subsidence issues.
With that qualification, Doctor.
It all depends on the long-term stability of the coal mine. And a lot of the effects that you see now in the area are long-term effects. As I said before, in long-term, these non-durable rocks deteriorate, and then that's when the instability occurs. I mean, I've seen it in many places where we're talking 50 years later, what reclamation is going to be around then to do that? Where, you have subsidence conditions.
No further questions. Thank you.
Thank you, Mr. Gilbert. Ms. Bluebird.
Thank you, Dr. Bagley. Good morning, Dr. Moreno. Again, I'm Linda Varden. I'm representing Bighorn Coal here today. And I have just a couple of questions. I'd like to draw your attention back to the TR1 area in particular and to the page in your PowerPoint where you have geologic conditions and you have the K prime cross section.
Okay.
And you're familiar with
I think I know what you're talking about.
with that, and you referred to the block 1 and block 2 areas. Is that your understanding that that's also the TR1 area?
Yes.
And you referred to that gray unconsolidated backfill area, and for the council's benefit, I have a hard copy here if you have reason to want to refer to that, but this is the page from the PowerPoint. I don't have a page on the PowerPoint to refer to.
I think I've seen that enough. I dream about it.
And
More cross sections than you wanted to see.
Dr. Marino, as I understand, is geologic conditions, it shows the strata and the variability of the strata across that K prime cross section. Is that correct?
Yes.
And I understood your testimony to understand that that unconsolidated backfill is saturated with groundwater. Is that correct?
That's what I understand from other testimony. I would expect it to be.
Okay. And do you, and I appreciate your testimony on slope stability, but I want to move past that and talk about your opinion on the impacts on the risk of subsidence, if any. If that backfill is cut through, as we heard about in Sheridan, and that groundwater from the backfill then is drained down into the various strata below the backfill, which would constitute the roof, the mine area, and the floor.
I haven't really done a detailed analysis of what the groundwater flows are. I mean, if water gets into the works below, it's gonna affect, those non-durable rocks.
And one last question then, following up on that, and this is also referring to a page in your PowerPoint called, entitled Mine Stability Principles. And it had a subtitle, Oscillating Groundwater Level Within Mine Void Interval. Do you recall that page?
Yes.
And were you present for testimony during the earlier part of the proceeding where there was discussion that although it's not mentioned in the mine plan at this point, there's a possibility that a sump or a pump system would be installed to drain that groundwater as it flowed down into the mine works? Did you hear that testimony?
Yes.
So could you tell me, relative to your mine stability principle chart here, if there is a drain and subsequent pump feature that would cause variability to the groundwater level, could that too affect the subsidence risk?
Objection, Dr. Bagley. I apologize for sounding like a broken record. These opinions are not in Dr. Marino's expert report. It's the reason the report exists. We would object to him testifying.
Dr. Bagley, I'm referring specifically to the PowerPoint based on his report that talks about mine stability principles related to the fluctuation of water level from pumping and relating it back to prior testimony.
The specific opinion about the TR1 area, the pumping, draining, groundwater in that area is not in his expert report.
No, the question though is how will the potentially changing water levels due to pumping affect subsidence? So I'll allow that question.
Thank you.
Pumping, on and off pumping is going to cause fluctuation in the groundwater levels. But again, it comes down to not having any detail. I mean, we don't have the detail. Where's the pump going to be? What's the capacity? We don't have any of this. This is all conceptual cloud in the sky stuff. I mean, as engineers, we don't work off cloud in the sky. We have hard calculation, we have analysis, we have the ground truth to assess whether a project's going to be successful or not.
So do I understand correctly that you saw no data in the mine permit application related to groundwater levels, groundwater fluctuation, or pumping?
I want to say that I did not focus on the hydrogeologic conditions.
Thank you. No further questions.
Thank you, Mr. President. Mr. Coleman.
Thank you, Mr. Hearing Officer. Just have a few. Dr. Marino, have you ever worked on a mine site in the Powder River Basin before?
I don't believe so, no. I did an overall geotechnical study of rocks from various coal fields, and Powder River Basin was part of that study.
Have you ever worked on a mine site related to the Masters or Kearney coal seams?
No. But I understand that there hasn't been a permit since 1980 on coal mining. Maybe I'm wrong, but that's what I heard from testimony.
Well, it sounds like you don't know that yourself, correct?
That's what I heard from testimony.
You're not familiar with what is required by Wyoming law for a permit application to be technically adequate, correct?
I don't claim to be a legal expert.
That's all my questions. Thank you.
Right.
Mr. Coleman.
Thank you, Dr. Bagley. Good morning, Dr. Marino.
Good morning, Mr. Pope.
I know you're probably somewhat disappointed Mr. Sutphin is not in this seat.
He said he's going to send me a postcard from Italy. We'll see. I
Let's,
gave him my business card, so.
well, I have no doubt he will send you one. let's talk about something I think that you and I can agree on. You would agree that it's important to understand the method of mining proposed by a mine applicant to evaluate the potential risks of subsidence?
You have to define what you mean by method of mining.
Sure. Are they going to do, what I mean by that is you agree that identifying whether it's a surface mine, high wall mine, long wall mine factors into evaluating the subsidence risk.
Well, an open mine or open pit, I don't understand how that would relate to subsidence.
Dr. Marino, understanding that, my question though is a simple one. You agree that understanding the type of mining, the method that an applicant proposes to use matters in determining subsidence risk?
To some degree.
In the instance of the Brook permit application, at least in preparing your expert report, you consider the high wall mining method that Brook intends to use as the same method as room and pillar mining, right?
No. What I said was that you end up with a room and pillar configuration. In fact, a lot of the older mines have.
Dr. Marino, I'm sorry, it's a yes or no question here. And I understand the desire to explain it. I'm sure your counsel will give you that opportunity. But I just want to be very clear. Is it your testimony today that you do not consider high wall mining and room and pillar mining the same?
I consider them, in terms of mine stability, the same.
But you're aware, though, that in the high wall mining method that Brook intends to use, that as the coal pillars run the length of the mining, the Brook mine is not going to then come and cut perpendicular into those webs and pillars, right?
Yeah, there will be no crosscuts.
You would also agree with me, Dr. Marino, that you have not reviewed any literature on the continuous high wall miner that Brook proposes to use at its mine.
I did look at a video of the high wall miner that's proposed.
Fair enough. My question, however, was you have not reviewed any literature on the proposed high wall miner Brook intends to use.
So can you be more specific? I mean, there was stuff on the website that I read. What are you specifically talking about literature?
Sorry, Dr. Marino, give me one moment. So let me be very specific to your clarification.
Thank you.
You have not looked at any of the literature or materials that any of the continuous high wall mining companies produce on the subject of their miners, right?
Can you repeat that? I'm sorry.
Sure. You have not looked at any of the literature or materials that any of the continuous high wall mining companies produce about their mining vehicles.
Dr. Bagley, I'm going to have to object on relevance grounds. I'm not sure what other companies and the miners those other companies may use have any relevance to this proceeding.
His ability to evaluate the subsidence risk, the subsidence control plan of the Brook mine, as he said on direct, depends on input data. One of the pieces of input data is how the mine works and how the miner will engage the rock that will hold up that area.
It's related, not as directly as you might see, but go ahead and answer that question.
I have not, whatever literature you're talking about, I have not looked at. The only thing I have looked at was some general information that's provided on the website by the manufacturer. and what's given in the permit.
On direct, you testified about some experience you had relating to figuring out if an area is undermined beneath the structure. You had some experience with that. You're aware, though, that there are no structures on the surface in the areas where the Brook mine proposes to mine, correct?
I am not aware, but I did not study that. My task was to determine subsidence potential.
Let's talk about your review of how a permit comes to be in Wyoming. Mr. Coleman asked you a question similar to this, but you've talked about the purpose of a subsidence control plan, both in your report and on direct, but you did not review the Wyoming statutes for what is required in a subsidence control plan, right?
Objection, there's actually not a statute that references the subsidence control plan. So I'm not sure what Dr. Pope, or Mr. Pope is even talking about at this point.
Dr. Bagley, my point is that he didn't even look at the law to figure out what the standards are for a subsidence control plan, but then testify about what is required for a subsidence control plan. That is directly relevant to whether the permit is accurate and complete.
The question, as I hear it, is you looked at any of the Wyoming statutes, regulations? We can ask that question.
Dr. Marino, do you need me to repeat the question?
No. I looked at a few brief phrases that were shown to me, but I did not study the Wyoming regulations.
Similar question here. You also did not review any Wyoming regulations on what is required for a subsidence control plan.
I think asked and answered, he just testified to that.
What's the difference in the question?
Well, there's a difference between a statute and a regulation.
So he said no to the regulations. You want to ask him about the statute? Is that-
I asked the statute question first. Now I'm asking him about his review of the regulations.
Okay. Go ahead and answer.
Same.
Same answer. Thank you. Similar question, and probably have some smirking faces in the room. You also did not review any DEQ guidelines for what is required as part of the subsidence control plan, right?
And I raise the same objection. There's not actually DEQ guidelines on a subsidence control plan. So,
Dr. Bagley, the point here is that to provide expert testimony on what is required in a permit application would require someone to go look at what actually is required as part of a permit application. And even if there isn't anything that's required, that should serve as the basis for offering an opinion, expert or otherwise.
Yeah, you're asking about legal stuff. And he's a technical expert. But you can go ahead and answer the question.
I did ask that question of council, and they basically, their response was, there's not much on it to look at.
Fair enough. Thank you, Dr. Marino. Getting back to the permit application, you also didn't review any of the comments and responses that went back and forth between Brook and DEQ, correct?
After my deposition, I did scan through those, yes.
But not before, right?
No.
So, for example, at least at the time of your deposition and at the time you prepared your expert report, you weren't aware of any subsidence-related comments DEQ had submitted to Brook Mine.
No.
You also didn't ask any questions of DEQ personnel in their review of the Brook permit application, right?
No.
And as a result of that, you don't know the qualifications of the folks in the District 3 offices and in the Cheyenne office of DEQ who reviewed the permit application.
No.
You mentioned on direct that you have never seen MSHA referenced in a permit application, and that your experience has more been there is.
objection, that's not what he stated.
Dr. Bagley, I explicitly heard him say that he had not seen as part of, and maybe I wasn't clear in the question, as part of subsidence issues discussing MSHA and actual MSHA.
Yeah, ask the question more clearly, please.
Sure. Dr. Marino, I heard you testify on direct that in your experience in terms of evaluating subsidence, you had not seen in a permit application a discussion of further work with MSHA. You also said that in your experience, a permit will have a lot of site-specific data on one area, and then it will go through a significant revision process as it moves on. But you, despite that experience, have no experience in permitting a new coal mine in Wyoming, right?
Objection, and
It's like
I'm gonna have
multiple-
to, sorry, I'm gonna have to object to the form of the question. I had a really hard time following. There was like at least 3 separate things in there about
You made
MSHA,
several- I got lost.
I'll simplify the question. Dr. Marino, you have no experience in permitting a new coal mine in Wyoming, right?
As I said earlier, there hasn't been one and I haven't been.
Let's talk about the ground control plan. At least at the time you prepared your expert report, you were not aware that the Brook permit application had a commitment to do further engineering studies, right?
I think there's an inference of that in the permit, in the application. That there, that there was gonna be that in essence, the MSHA ground control plan was gonna make the subsidence control plan complete.
But you're at least aware now that Brook will have a ground control plan approved by MSHA in place before it begins mining?
I don't think they could mine without it.
You're also aware that as part of preparing and getting approval for that MSHA ground control plan, that a professional engineer will have to stamp the ground control plan, right?
Objection, actually. Mr. Pope was raising all kinds of objections to the MSHA permitting process, and now he wants Dr. Marino to testify about it.
Well, that's probably because of the question being asked. Yeah, we can go ahead and answer that question.
Dr. Bagley, do you need me to repeat the question?
No, I understand what you're saying. I would expect it to be signed and sealed.
We're going to pull up on the screen for you, Dr. Marino, DEQ Exhibit 5-017. Could you blow up the bottom paragraph, please? Can you see that okay, Dr. Marino?
Yes.
Okay. I want you to go down to the second sentence, and you had mentioned that there was no strength data in the permit application. Here on DEQ 5-017, it says that laboratory strength analysis was conducted on 4 samples from 2 locations, R13-019 and R13-023, and results provided in addendum D5-5. Did I read that correctly?
Yeah, I would like.
Dr. Marino, my question was simply, did I read that correctly?
Yes.
Thank you. Let's go to the next page, please, DEQ 5-018. You can blow up the top paragraph, please. Thank you, Gary. Can you see that all right, Dr. Marino?
Yes.
I'd like you to look at the sentence that begins, it is understood. Here it says, it is understood that due to the nature of the area and the strike and dip of the coal seams and the ever-changing overburden and interburden thickness, that these samples will not represent all conditions encountered by the continuous miner. Samples will be collected and strength testing will be conducted on those samples in order to satisfy the requirements of the MSHA ground control plan, which must be approved prior to mining. Did I read that correctly?
Yes.
Goes on to say, the future testing results and analysis in preparation of the MSHA ground control plan will be provided to WDEQ/LQD. Did I read that correctly?
Yes.
Can we go to the next paragraph, please? Can you see that, Dr. Rain?
Yes.
Here it says the results of the tensile strength tests will be utilized to size both the web pillars and barrier pillars to achieve a factor of safety as set by the MSHA ground control plan to conduct mining and minimize the risk of subsidence. Did I read that correct?
Yes.
I'd like to go now to Brook Exhibit 10D. We'll put that up on the screen. Just blow up, carry the title. Please. Dr. Marino, is Brook Exhibit 10D the District 9 high wall minor ground control plan check sheet?
I guess it is.
Just a point of clarification for the council, are you familiar with MSHA District 9?
No.
Do you know, and it's okay if you don't, but do you know that District 9 is the district within MSHA that regulates the state of Wyoming?
I actually talked to some MSHA officials. I thought that they were the ones that, I don't remember the district number, but the ones that were in charge of any permitting for the Brook mine, for open pit mining and high wall mining. And they weren't not aware of any application or anything being filed.
Dr. Marino, my question was a little bit simpler than that. Are you
But
aware?
I don't remember, I'm trying to answer your question in that maybe they were District 9, maybe they weren't, I'm not sure.
And to be fair, and I don't mean to confuse you in any way, I'm not asking about people. I'm just simply asking, are you aware that District 9 of MSHA is the district that regulates the state of Wyoming?
And I still don't see what the relevancy of some of these questions are, but.
Dr. Bagley,
I think he's answered that question. I don't know, but.
and I apologize, Dr. Marino, if you said no, I did not hear that.
That's fine, no.
So let's I want to go into Brook Exhibit 10D. And Carrie, if you would, that long middle section there, if you blow that up, please. Dr. Marino, this is portions of the checklist that, in preparing a ground control plan for MSHA, a mine must include. It says in subpoint A, slope of the ground to be mined.
Yes,
The next one under that is maximum high wall height.
yes,
Then C is high wall slope.
yes,
Underneath that in subsection D, it says width of high wall benches.
yes,
All right. You would agree with me that this information, based on what you testified on direct, are some things that you would recommend the Brook Mine study and provide engineering detail?
yes.
Here, would you mind shrinking that, please, and going down to the bottom bullet, please? Dr. Marino, this is another bullet, and it says stability. And there it says use of ARMPS, ARMPS. I believe you testified on direct that program is an industry standard, is that right?
Yes,
And below that, it says for this checklist that the stability must have a minimum overall safety factor of 1.3, right?
Yes,
And as you said on direct, the safety factor is very important, right?
yes.
We're going to go to the next page in Exhibit 10D. Sorry, Dr. Marino, give us one moment.
No problem.
Here, can you pull up the top text, those two ones at the top, please? Thank you. Dr. Marino, this portion of the MSHA ground control checklist continues the safety factor discussion. You would agree with me here. It says that the ground control plan should include a drawing showing depth of overburden, height of pole, maximum number of poles between barriers, barrier and web dimensions used to calculate 1.3 stability factor.
Yes.
There was some discussion on direct and on cross with Mr. Gilbert's about the difference between bituminous and subbituminous coal. Do you remember that?
Yes.
You're aware that the ARMS program required by MSHA includes an analysis of both subbituminous and bituminous coal.
No.
You're not aware of that?
I in fact talked to the individual, who's a colleague of mine, Chris Marks. And in fact, I talked to him about subbituminous coal.
Dr. Marino,
strength.
I apologize for interjecting again. My question was simply, are you aware of ARMS using both bituminous and subbituminous coal?
I think he's trying to give him the answer if he'd just let him.
My question, Dr. Bagley, is just, is he aware? That's a yes or no?
Not necessarily. Go ahead and continue with your answer.
Okay. I know the person well, Chris Mark, his Mark Beniowski equation. And I emailed him about subbituminous strengths. And he said he had no information on it. He actually gave me one reference that was kind of, gave one or two strength values. So I doubt, since he is the one that developed this program, and one I talked to recently, and from my review, I don't remember saying anything about subbituminous strengths.
Maybe we've gotten our wires crossed here, Dr. Marino. Let's just back up and ask a much more general question. Are you familiar with the ARMS program?
Yes.
Have you used that software?
Yes.
Have you looked at whether as part of that program looks at both bituminous and subbituminous coal?
I am aware of that there is no subbituminous strength coal that's given in the program.
You mentioned that MSHA's goal is the safety of miners, right?
Yes.
So at least in your experience, MSHA doesn't want a mine area to cave in because it could endanger the safety of miners, right?
Objection, again, I mean, Mr. Pope was trying to limit Dr. Marino's testimony about MSHA and his expertise related to what MSHA does or doesn't do, and this is calling for that testimony. So, I mean, I'd like to revisit some of his earlier objections, but.
Dr. Bagley, as you said, you allowed this testimony. There was discussion about the mission statement.
I think it's relevant. Go ahead.
Can I give a qualification to my answer?
Sure.
So can you ask the question again, please?
Absolutely. You would agree that MSHA, because its goal is to protect miners, doesn't want a mine area to collapse because that could endanger the safety of miners.
Yes. And one of the distinctions that you have is ground control. Ground control is typically related to safety. So we're looking at short-term conditions when the miners are in there, not when it's abandoned. So the safety factors that you would use and what you're concerned about is just the local cave-in, that, small cave-ins that can hit a miner and cause injury. Different focus than, is it going to chimney up in a year or 3 years or 50 years? So they don't look at that.
Thank you, Dr. Marino. Let's talk about some of the substantive conclusions you drew in your expert report. I'd like to pull up on the screen DEQ Exhibit 12-121. Dr. Marino, do you recognize this as figure MP.1-3 from the Brook Mine Plan?
I don't remember the trees and I don't think that's in my exhibit, is it? I don't think so. And then these other cloudy spots.
So is that a no, you do not recognize this?
I'd have to look at it in detail, but it looks generally correct.
Okay. And it's fair to say that you used this schematic in preparing the cross-section we saw that had web and pillar heights and widths, right?
Yes.
Carrie, can you highlight the very bottom where it says figure MP1-3? Dr. Marino, you're aware that this states that it is a generalized schematic of the highwall mining operation?
Yes, and if I can give a qualification?
Not right now. If you would exit out of that, please, Carrie, and blow up the nomenclature. Section, please. As we mentioned a moment ago, you use this in developing the heights and widths in the figure in your report, right?
I use this to develop the heights and widths. No, I got the heights and widths from the text.
I'll ask a question about that in just a moment. Dr. Marino, you would agree with me that the figure MP1-3, which is a generalized schematic, indicates on it that it is not to scale?
Okay. Yeah.
You mentioned just a moment ago that you pulled the heights and widths from the permit application. Dr. Marino, you would agree that there are no specific heights and widths for any of the trenches specified in the permit application?
We're not talking, this is not related to what you're talking about. You're talking about trenches, right?
Let me re-ask the question. If I got
Yeah,
you
I was gonna
confused,
say.
please let me know. You stated a moment ago that you took the heights and widths for various web and barrier pillars from the text of the permit application, right?
I took for this diagram, I took the width of the openings in the pillars. And I also put on the drawing the potential extraction heights range that the miner can utilize.
And I want to be clear here. I thought I heard you testify a moment ago that you took the heights and widths of barrier and web pillars from the text of the permit application. Is that true?
Are we relating to this drawing, or are we just talking in general?
I'm talking in general in terms of your opinions about heights and widths and how they factor into stability and subsidence.
Okay.
My question is it true that you testified a moment ago that you pulled the heights and widths of web and barrier pillars from the text of the permit application?
I pulled the width of the openings in the pillars from the text. I determined the heights based on the cold thicknesses that were provided.
All right, I'm glad we've cleared that up. My ultimate question is, you're aware that the text of the permit application does not state anywhere the heights and widths of web or barrier pillars for any of the areas in the mine.
It just gives typical, it says typical. And that's, comes to the crux of the matter. There's nothing to go off.
Understanding that, Dr. Marino, I want to turn to extraction ratios. You testified on direct that you believe the extraction ratios are somewhere between 60 to 70%, right?
Yes, in the panel areas.
Yes. So you're aware that the permit application states that the extraction ratios will be 45 to 60%?
Can you show me where that says that?
Dr. Marino, my question is simply, are you aware that the permit application states the extraction ratios will be 45 to 60%?
No.
You testified on direct that there was no strength data in the permit application. I'd like to go to DEQ 5, Exhibit 5-202. In this portion of addendum D5, you would agree with me, Dr. Marino, that this section states it is the unconfined compressive strength, ASTM D7012, method D.
Yes, I've reviewed that actual.
Let's turn to
standard.
the next page, DEQ 5-203. I'm going to blow up the table in the middle of the page. Near the right-hand side, there is a heading that says compressive strength, and in parentheses it says PSI. Do you see that, Dr. Marino?
Yes, I'm familiar with that too.
All right. And on the left-hand side, there is a portion that says rock type, and it says coal underneath it, doesn't it?
Yes.
And the PSI, the compressive strength in PSI for the coal, at least for boring R13-019, is 1460 PSI, right?
Yes. Can I qualify?
I'm sure Ms. Anderson will give you that opportunity.
Okay.
You mentioned near the end of your direct that your review is that there should be the subsidence in the area should be unlikely as a result of mining, right?
Say that again?
I jumbled my own words up. I apologize. Your opinion in your expert report and what you testified on direct was that the subsidence control plan and the permit application should be designed such that subsidence is unlikely, right?
Yes.
But you would agree that the unlikely standard you have used does not come from any Wyoming statute, regulation, or DEQ guideline.
Yes.
Dr. Marino, you spoke with Ms. Anderson about a picture of the permit area, and it had pockmarks of subsidence. Do you recall that?
Yes.
And there was as I recall, there was a yellow line around that area, right?
Yes.
You would agree with me that that subsidence in that area is likely from historic mining in that area?
Yes.
But you're aware that even in the areas of historic mining, there are places where there are no subsidence, right?
To date, yes.
And you're also aware that the historic mining done in that area was often a room and pillar method where they retreat mine the pillars, right?
I am aware that in certain areas that's the case. I don't believe that's the case in the area outlined above.
And I want to be clear so we all know what we mean. Retreat pillar mining is a method by which, as the mine exits the area it has already mined, it extracts the coal pillars holding up that area, right?
Yes, or in other words, second mining. And when you do retreat mining, normally that's considered planned subsidence. There's two ways a subsidence control plan can operate. One is unplanned, one is planned. Planned is where you have high extraction mining, and they extract the pillars, and they plan for the surface to collapse, for subsidence to occur. And it's done in a controlled way. And they know about approximately how much subsidence occurs. So if you have structures, you have some idea of when that structure is going to be subsided, and you can take mitigation measures to help assist with any subsidence damage.
Dr. Marino, I heard you testify on direct that, at least in your experience, you had never seen a permit that said 1 month before mining, it'll submit a design. You recall that?
I didn't say it in those words, no.
All right, but I did hear you say that at least there would be a 1 month time gap between submitting the design and mining. You're aware, though, that the permit application does not state that the ground control plan will be submitted 1 month before mining begins.
Okay, are we talking about the subsidence control plan or the ground control plan?
Ground control plan.
So can you restate your question, please?
Absolutely. You're aware that the permit application does not state that the ground control plan will be submitted 1 month before mining begins.
I don't know, I don't remember, but I don't see the relevance. I mean, we're talking about a subsidence control plan, not a ground control plan.
I understand there's at least a disconnect between Brook and everyone else on that front, and that's fair. You're aware, though, that before any mining can take place at the Brook mine, MSHA must approve a ground control plan.
Yes.
Dr. Marino, thank you very much. I have no further questions.
Thank you.
All right, thank you. Mrs. Stu and I, Nick, do you have any questions?
No, the questions that I had written down all been answered. Thank you.
I have some questions, Dr. Marino. Thank you for coming back. So I guess I have a minor complaint. I would have liked to see the formula, but I guess that's just me.
It's that being an engineer.
Oh, well.
We can submit it later if you want, if you need to see it.
I was. Just let me go back to a question. You were talking about your experience. As I listened to the testimony and try to understand what the plan is, my understanding kind of boiled down to that there's 7 major areas or trenches that would be
construct it over time, and then they'll go in and construct a box cutter trench, or whatever they call it, and go in and high wall mine, and then move on to the next one. Would you expect, just in your experience, that you'd have detailed subsidence plans for all 7 of those prior to starting one?
Yes, yes. I mean, to me, the most reasonable way would be you prepare one for one trench or 2 trenches, and you have all the information you need. You get that approved, and then you have significant revisions after that. That's provided in the regulations that I understand from other states, and I assume they exist in Wyoming because they're federal standards. And so you would submit, okay, I want to now trench mine 3 and 4. Here's the data, here's the analysis. DEQ reviews that. There's a public hearing about it. And then if it gets approved, and they go ahead and do their work.
Okay, so let me just think you answer my question, just let me be sure. So I want to go and do TR1.
Yes.
And so I should have a detailed subsidence control plan, detailed technically by our definition of technical, prior to being allowed to mine that. But I don't necessarily need one for TR2.
Right.
Okay, so of all 7 that are shown, we really should have 1 defined, but then before they go to the next one, we'd expect to have
A significant revision.
A significant revision.
Yes.
Okay. Thank you.
And if I can add, I just worked on one for Illinois where the mine is quite old. In fact, they've had a permit since the early 80s, and they've worked off significant revisions over the years. This last one was about mining underneath an impoundment, reservoir impoundment. So I was consulted by the city to look at the significance of mining, and we worked out a plan of how to protect those dams, okay, subsidence-wise. And that was all in the subsidence control plan. There was no MSHA involved. MSHA had nothing to do with it. It was more the effects of the surface on the public.
Okay, good, thank you. So the question that folks have danced around, I guess, I'll just try to answer it, and it doesn't have to be a yes or no answer. In your opinion, will subsidence occur at the Brook Mine facility?
Given the description of claystone, and I talked to you about, look, I'm concerned about slope stability problems, but it's not a subsidence issue. That's more MSHA. But if you have claystone, it's going to break down to a point where it's going to be soil-like. So if you don't take those things into account, I believe we're going to have subsidence problems. And there's no testing or anything to tell us otherwise that, how that's going to be mitigated.
Okay, so, because you had said in one of your conclusions, and I have a couple of quotes around it, serious subsidence risk.
As the permit, as the data exists in the permit currently.
Okay, so there's a serious subsidence risk, and the reason for that, in your opinion, is that there just are not enough data to know one way or the other.
And just that the description of claystone, which, as I said in my deposition, that I don't believe it's claystone, but as an engineer, I work off what is given. It says it's claystone, but testing can prove it wrong and say, no, it's not claystone. It's a siltstone. It's, shale that's durable. That changes the picture completely, right? But we don't have the engineering data. It's all just narrative.
Okay. So that's what I thought. I just wanted to be clear. I understood that. I'll ask this question, and again, this doesn't have to be a yes or no answer. Actually, it's a question I'm asking you as an expert, simply because it's a question the council has to try to figure out too. If there's subsidence, will it cause any problems?
Well, that's an environmental question, environmental engineering question, geohydrologist question, which I can only speak for subsidence risk. If it was structures, I could expound upon, because I've done a lot of analysis of damage of structures and pipelines and that sort of thing for subsidence, but environmental, agricultural issues, that's an agricultural engineer or some, environmental engineer.
Okay. That's all right, worth a try.
Yeah.
Now, we saw a District 9 form provided that had to be submitted, presumably District 9 of MSHA. In your opinion, would completing that form, regardless of when, I'm not asking when, I just completing that form, would that provide you enough information to further evaluate the subsidence risk?
Further evaluate, yes. Sufficient? I don't think so, because they're concerned about mine safety, and their concern is short-term. So you see the safety factor of 1.3, that's a short-term safety factor. Long-term is going to be 1.6 to 2, depending on the design, type of design. So again, the different focus. Therefore, we showed you the mission statement. This says nothing about subsidence in it. They're more concerned about, safety and health issues related to mining.
So by completing that form, which looks like it would require a lot more sampling than currently.
Absolutely, it will.
It still may not provide enough information to deal with long-term subsidence issues.
Right, and the difference, we don't have, what we have here is we don't have miners going into the entries, right? So this is all done remotely, so they don't have to worry about caves. The only thing they have to worry about is the instability of the mine as it affects the slope. You follow what I'm saying?
Mm-hmm.
So the near field effects of instability on the slope, because then you can have a slope failure.
I guess I imagine they may also be worried if it subsides in on a continuous miner, there may not be a person in that mine, but still they may be considering it in that manner. I guess I'm not. Yeah, I see what you're saying.
Yeah, how would you go back in? You have to in order to go into an entry, you have to have a roof bolt plan. It's called a roof bolt plan. And it's basically steel bars that you nail into the roof that hold the roof stable, keep it intact. They're not going to do that in this case because it's all remote minded. So there's not going to be miners going in. And if there is, they have to do this whole roof bolt plan. And that's going to be extensive to do that.
Okay. Thank you. That's all my questions. Before we go back to redirect, I just want to get an idea, Ms. Anderson, how long do you think redirect will take?
Not long, I don't think. I think you actually covered some of the questions we were just going to cover. So
one suggestion is you're probably going to be a lot more efficient if they take the lunch break. You can probably be way more efficient with it.
Well, that's what I'm getting at.
yeah,
Should we take, it's 5 to 12. Should we take a lunch break? Or like if you have 1 minute of redirect?
oh, it's going to be a little bit longer than that. Yeah.
So let's go ahead and take a break for lunch. We'll be back here at 1 p.m.
Okay.
All right.
Yeah.
Yes. I'll let you know.